In this video, we are going to talk about the three different types of experimental designs. And to do our three different types of experimental designs, we're going to use the same kind of background example. And that was where we had our students that were going to take an SAT prep course in hopes that we can increase our SAT scores. Now, the first type of experimental design, this is the most basic, the most common experimental design that we can do, and it's called a completely randomized design, or you may abbreviate it as a CRD, just like simple random sample was an SRS. So a completely randomized design is like an SRS in that it is the most basic way that we could do a sample like an SRS, and a CRD is the most basic way that we can do an experiment. So anytime that you are asked to kind of outline the design of an experiment, this is what you're going to do. You're going to basically kind of draw out it's almost kind of like a tree diagram, if you will, that really just kind of outlines what's going to happen. And so first we're going to start with our subjects, which were our 180 randomly selected students. So we're not paying attention if our students are juniors or seniors. We're just saying we're going to take everybody that's in our random sample. And hopefully they're random, because we discussed before what happens if they're not random. We can still take them, but the results may only apply to certain people and not necessarily our whole population. So we start with everybody, and then we said there were going to be three different levels for our SAT prep. We were going to have a teacher-led SAT prep course, and then we were going to offer an online self-prep course where students would just take their time going through the prep course, and they would get through everything, but it would be more self-driven. And then we said we would offer some students no prep course, because we want to have some sort of control group, a baseline comparison to our two different types of actual prep courses. So we need three ultimate treatments here. But whenever we set up our experiment, we first need to put our preferably equally split up 180 students into three groups of 60 students each. Does it have to be equal sizes in each group, in 60 and 60 and 60? And it doesn't, but it really makes it for a nicer comparison if we have the same number of students in each group. So notice the RA that I have here. This means randomly assign. We're going to take our 180 randomly selected students, and we are going to randomly assign them to three groups. So the groups are basically like a waiting room, if you will. So we're going to randomly assign 60 students to group 1, 60 to group 2, and 60 to group 3. And once those students are in their respective groups, then we assign a treatment to each group of students. So maybe treatment 1 is the teacher-led prep course. Maybe treatment 2 is the online self-guided prep course. And then maybe group 3 is the no prep course. And then after the students go through their prep courses and they take the SAT, then we can collect their scores. And ultimately, here at the very end, here is our response variable, which was to compare the SAT scores. So the outline, if you will, of a completely randomized design is we start at one specific point with all of our students, with all of our subjects. We split them up into groups. We give each group a specific treatment. And then at the end, we bring everybody back together so that we can compare. Now, going back to that random assignment. So we're not really talking about randomly selecting these students, but we do need to randomly put them into the groups. So the same idea kind of holds from the first half of the chapter where we randomly selected people. So if we needed to discuss, well, how are we exactly going to randomly assign 60 students to each group? We're going to run through our three different ways that we did of doing a random sample. And that was using like the HAP method, it was using the random number table, and it was using technology. So I'm going to go through how we could randomly assign our 180 students to three groups of 60 students each. So first with the HAP method. What we could do, and again, these are just one specific way you could do this. There are other ways that you could accomplish this, all right? So this is a little bit different. So I'm saying let's label 3 pieces of paper with a 1, a 2, and a 3. Okay, we only got 3 pieces of paper. Now you could say let's write every student's name on 180 pieces of paper and put them in a hat. But in this way, we only need 3 pieces of paper to represent the 3 groups. All right, so we got 3 pieces of paper. Again, they should be equal sizes. If you fold them the same way, but we're going to mix them up in a hat. And then we will have each person randomly select a slip of paper. So let's say person 1 comes up, selects a slip of paper, and it has a 2 on it. Then we would assign that person to group 2. And then that person puts the slip of paper back into the hat because somebody else could also be in group 2. So we will continue that process until one of our groups gets to 60 people. So let's say, for instance, that group 2 was the first group that got to 60 students. Once that 60th student selects group 2, then basically we would keep group 2. We would take that slip of paper and leave it out of the hat so that only 1 and 3 were left over. And so we'll continue then, once we've got one group done, we'll continue until another group has 60 students. So let's say group 1 is the second group that finally gets to 60 students. Now, all the other students, by default, will have to go into the final group. So when I say into the third group, I don't mean group 3 necessarily, but just whatever group didn't have 60 students at the end of the random assignment. Okay, so this is one way that we could accomplish this. And I think this is easier than using 180 slips of paper. But you could do the 180 slips of paper. You could say, I'm going to pull out 60 names out of the hat. All of those students go into group 1, and then I'm going to leave them out of the hat. Select 60 more pieces of paper, and the names on those go into group 2, which means all the leftover 60 pieces of paper that are in the hat after that point will go into group 3. So that, again, would be an acceptable way of randomly assigning them. Now, using technology, we could label each student 1 to 180. We don't have to use triple digit numbers for all students because a random number generator with a computer or a calculator can differentiate between single digit numbers, 2-digit numbers, and 3-digit numbers. So we would use our random number generator, or using technology in general, or using our calculator. We need to randomly select 60 unique numbers between 1 and 180. And we'll say we'll just assign those people to group 1. And then we need to select 60 new unique numbers that have not been chosen. And we can put those people into group 2. And whoever hasn't been selected for group 1 and group 2, by default, goes into group 3. Now, for the random number table method, the only thing that's really going to change is in how we're going to label those students. So here's where we need each student to have the same number of digits assigned to them. So I would have to call student 1 001 and then go all the way to 180 so that each student has a 3-digit number attached to them. And then I could say, using whatever specific line, you could make up a line number if you wanted to, of our random number table, we need to select 60 unique 3-digit numbers between 001 and 180, and we would assign them to group 1. We can do the same process over again, but we need 60 new unique numbers for group 2, and then the rest go into group 3. The only thing I technically left out of this would be what would happen if we came across duplicates. You know, are we going to put the same person in group 1 again? We wouldn't. And we'd also need to talk about, what about any numbers like from 181 to 999, and also including 000. And so if we saw any of those numbers, we would specifically ignore them and go on to the next 3-digit number until we find numbers that are between 001 and 180. So I did say specifically, we are looking for numbers between 001 and 180. So because I said that, then technically I don't need to say what to ignore. But it's always good practice to say, well, what would happen if I saw these numbers that don't have students attached to them? And you can just include the ignore part. All right, so the 60 students, or not the 60 students, but the 60 seniors that have already taken the SAT, they did so with no prior prep course experience. Now, seniors tend to score higher than juniors because they have more educational experience, right? They've been to school a whole extra year, so typically they know maybe a little bit more than juniors would. So really we should experiment on seniors and juniors separately. But why do we really need to do that? One grade may do better with one prep course than the other. Like maybe seniors would do better with the online self-guided, or maybe the juniors would do better with the online self-guided than the actual teacher-led prep course. We don't know. So grade level is going to be a confounding variable that we want to try to control. And so we're going to control for grade level by using our second experimental design technique, which is called a block design, or you may see it referred to as a randomized block design. Now, whatever the confounding variable is that you believe there might be differences in, that specific variable is what we're going to block by. So a block design is really nothing more than doing a completely randomized design for each block. And in this case, we only have 2 blocks. We're going to do a block with our juniors, and we're going to do a block with our seniors. Now, if you had more than 2 blocks, then you would do a completely randomized design, again, for each of those blocks. So we're only really going to do 2 completely randomized designs, kind of parallel with each other at the same time. So here's what the initial part of a block design looks like. We have all of our students, but then again we said, confounding variable, maybe the seniors and juniors are going to do differently. They're going to respond differently maybe to these treatments. So let's split up all of the juniors and all of the seniors into their own separate blocks. Okay? So what looks like what we've done before with random assignment really isn't random assignment. One thing that I've seen students do time and time again is that they will split up the entire sample into however many blocks you need, in this case 2, but they'll say, we're going to randomly assign all the juniors to block 1 and randomly assign all the seniors to block 2. And it's not that you're randomly assigning them, you're like legitimately telling the juniors, you go to block 1. Hey, all seniors, you go to block 2. So you just need to say here, this is the blocking process where we're splitting them up. All right, so again, the blocking process is not done randomly. You are telling your specific confounding variable subjects to split up ahead of time. So now let's take a look at what an overall block design is going to look like for this situation. So again, notice at the very beginning, we have all of our students, but we said, there's going to be a difference, a potential difference between our 2 grade levels. So initially we split them up by block. We blocked them into 2 groups, 2 blocks, if you will. And we have all of our juniors up here, and we have all of our seniors down here. And then once we've blocked them, again, it's basically like we're doing 2 separate, completely randomized designs. So let me just kind of hide this bottom part here. So again, if we were basically doing a junior-only experiment, we would take our 120 juniors, ideally randomly assign them into equal-sized groups of 40 each, and then for each group, we would give them their appropriate treatment. And then at the very end, what are we comparing? SAT scores, but for only those juniors. The seniors aren't a part of this part of our block design. Then, on the bottom half, we have a completely randomized design for our seniors only. So again, we have all of our seniors, and we're going to randomly assign them to one of 3 groups. Again, ideally of equal sizes if possible, and we can 20, 20, 20. And then we assign the treatments to those 3 groups, and at the very end we compare just the senior SAT scores. So what we might find in the end is one of 2 situations. We might find that maybe for the juniors, the teacher group, they had a higher SAT score average than the online group or the nothing group. And maybe for the seniors, we find out maybe they're just fine with online self-guided and their scores were the highest. But we might also discover that maybe just both groups did better when a teacher was actually leading the SAT prep course. But again, we wouldn't know that that would happen unless we actually split up the juniors and the seniors and we kind of experimented separately on them. So again, a block design is essentially just multiple CRDs, completely randomized designs. Now, another confounding variable is a student's GPA, which may have a greater effect on SAT scores more so than grade level. Just consider you might have a senior who maybe doesn't have the best GPA, and they may perform differently. They may need more assistance, or they may respond better to a different treatment than another senior with a higher GPA. So we should compare students with similar GPAs to know which prep course method works best for students with varying GPAs. Now, this time around, we're going to ignore the no prep course option. Okay, so we're only going to focus on the teacher-led SAT prep course versus the online self-guided SAT prep course. Now, in this sense, we're going to use what's called a matched pairs design, because we're going to match together two students that have very similar GPAs. So the only difference is literally going to be the treatment that each of those two students would receive. So in a match pairs, we are going to manually pair together, get it? Match pairs, pair together, or it's kind of like we're really doing a block design, all right? But our blocks are going to only have two students each. And those first two students that we manually put together are going to be the two students with the highest GPAs. And again, we're saying, who cares if they're a junior or a senior? So we've got our best two achieving GPA students. And then we're going to pair together the next two highest GPAs, and then so forth and so on until we get to the two lowest GPAs, and they're paired together. Now, for each pair, it's going to be randomly determined which student gets the teacher-led versus which student gets the online-led prep course, because we always want to leave it to random chance who gets which treatment. We don't want to just manually say, well, you're going to get this one and then you're going to get that one. You're going to get this one, you're going to get that one. We'll always let random chance decide for us. So here's what a match pairs would technically look like. And this is where I didn't draw out the whole thing because it gets really, really crazy. So again, I start with all of my 180 students, and then again, I'm going to block them two at a time. So my first kind of block, if you will, there's my best two GPA students, and then I'm going to randomly assign one to receive treatment 1 and one to receive treatment 2. You might go, whoa, hold on. You didn't assign them to groups. That's true. I didn't assign them to groups, but consider there's only two students to consider here. So I can automatically just randomly assign them to a treatment, and then the other student's going to get the other treatment. So for a match pairs, you don't necessarily have to assign them to groups if you only have two people in your block, your little subgroup here. So then again, here's students 3 and 4 GPA. And again, randomly assign which one's going to get the teacher-led, which one gets the online-led, all the way down to ... our last two lowest GPA students. And then in the end, we would do a lot of comparisons. Like we would see what did best for our best two GPA students, what did best for number 3 and number 4 GPA students. Lastly, what did best for our bottom GPA students. So really, there's going to be how many total comparisons? There's going to be 90, right? We would take our 180 divided by 2 because we have 2 students per grouping. And so really, there's going to be 90 of these compare SAT scores. Now, what you might do is you might see some similarities between, I don't know, let's say the first 5 groups, right? If you have your top 10 GPAs, they might all be very, very similar if the difference between their GPAs isn't that much, okay? So you might consider that. Like maybe you only compare and really look at the results of every, 5 pairings instead of literally every 1 pairing. Now, there is an alternative to a match pairs design, and that's where the pairs in each group aren't 2 people that are very, very similar, but it's actually the same person. And so that same person gets to act as their own control group, essentially. They're going to get to experience both treatments. But we would let, again, randomness decide for us the order that the person would receive the treatments. So our prep course example is not really going to work out because I can't take myself and let me do the teacher-led SAT prep course, and then I also get to experience the online self-guided prep course, and then I take the SAT. Like, I now have went through 2 prep courses. So that example really doesn't work well in this situation. So what I found out, this is a hot button debate here, apparently Dasani water tastes like crap, according to some of my students. And so what I would do is put them under the test. Can you really tell the difference between Dasani water, and I picked some other bottled water, and I picked Aquafina. All right, so Dasani is a Coca-Cola branded water, and Aquafina is a Pepsi branded water. So basically, can you tell the difference between a Coke and a Pepsi water? So here's how that match pairs would look like. I would start with, let's say, 50 randomly selected people. Hopefully they're randomly selected, so I can apply this to the whole population. But if those people were not randomly selected, then the results would only apply to these 50 selected people or 50 people that are very similar to these people. So again, hopefully randomly selected. Now, I would split them up into 2 groups. Okay, so again, I don't just have 2 people, but I have 25 people that are essentially going to act as their own partner, if you will. And so in group 1 with my 25 people, I would, and notice the differences here, that these treatments are basically being flip-flopped, but I would give Dasani water to the first group. They would taste it, they would think about it, and then after some time, maybe come back 5 minutes, 10 minutes later, let the taste of the water, which does water really have a taste? Some people are like, absolutely. Some people, I don't know, tastes like water. Then I would let them try the other water, and let's say it would be the Aquafina. Now, the people don't know, again, which water is which, but for group 1, I would give all 25 of these people the Dasani first, and then the Aquafina second. And then I would say, all right, you tell me, which water was the Dasani, which water was the Aquafina, and they have to be able to identify. And they're either going to get it right or they're going to get it wrong because there's only 2 possibilities of water choices here. Now, there might be a scenario where maybe Dasani really is that grossly disgusting water, and so I want to, for the other group, swap the treatments. Okay, so maybe in group 2, I let people drink the Aquafina water first, and then let them try the Dasani. So again, there could be some difference, and I want to kind of leave out any kind of lurking variables I'm not considering from producing some bias in my results. So for one group, they get one order, Dasani, then Aquafina. For my second group, I'm going to give those 25 people first Aquafina, then Dasani, and then ask them to identify which one they think was which water. And then in the end, I can bring everybody back together and compare how many people really got it correct. Could they really tell a difference, regardless of which one they tasted first? So that's really what our 2 groups are acting as, maybe there's some difference. Okay, so now we're at the you do, and we're going back to our eyes on cow butts. So after the success of determining painted eyes on cows' rears to help deter lion attacks, researchers want to test different color combination of eyes. So they randomly assign 1,000 cattle to one of 2 treatments. We're either going to have yellow eyes outlined in red, like over here on the right side, or will white eyes outlined in black be any better, any worse, or does it really matter? So what I want you to consider first is draw me an outline of a completely randomized design. And again, all I'm looking for here, going back to the completely randomized design, is something that looks like this. But do this with the cow example. And give me as much detail as you possibly can. There we go. So do that for part 1. Part 2. Researchers believe the color of the cow itself may play a role in whether it is attacked. So they have 350 brown cows, 400 white cows, and 250 black cows. Now I want you to draw out a block design addressing the cow colors. And last but not least, other researchers believe the size, aka the weight of the cow, plays more of a role in whether it is attacked compared to the cow's natural color. So now outline a match pairs design addressing this. And that is all. Good luck. We'll talk about this the next day in class.